All right, let's just jump right in. We're going to talk about something every single Python coder runs into. You build this awesome script, it crunches some numbers, it spits out some incredible data, and then you close it. And poof, it's all gone. So today, we're going to fix that. We are going to build a permanent home for our data. I mean, really think about that for a second. All that hard work your script just did vanished into the digital ether. It is so frustrating. But it's also the perfect reason why we need to learn how to store data properly. We need a way to make it stick around long after our script is done. So, first things first, if our data is going to have a home, we need to lay the foundation. And I'm not talking about just dumping it in a text file. No, we're going to create a real structured database file right from Python. And you know what the best part is? You don't have to go out and install some complicated new software. The tool we need, SQLite, which is literally the most used database on the entire planet, it's already baked right into Python. It's on your computer right now, just waiting for you to use it. And it seriously only takes 2 lines of code. First, you just import SQLite3 to get access to all the tools. Then you use SQLite3.connect, and you just give your database a name. And here's the magic trick. If that bookscollection.db file doesn't exist yet, this command creates it for you. Just like that. The foundation is poured. Okay, so we've got our foundation, this empty database file. But now we need a way to actually, do stuff inside of it. We need a worker to follow our commands. And in the database world, that worker is called the cursor. Let me put it this way. Think about using Excel or Google Sheets. You move your mouse pointer around, you click on a cell, you type something in, right? Well, in a database, the cursor is your mouse pointer. It's our little digital worker that goes and executes our commands and actually does all the heavy lifting for us. And making one is, well, it's about as simple as it gets. You just take that database connection we made, the one we call DB, and you ask it for a cursor. Boom, 1 line of code. Now we have our worker ready and waiting for instructions. All right, foundation, check. Worker, check. Now it's time for the fun part. We get to draw up the blueprints for our data's house. We need to define the rooms, the rules, what goes where. We need to design the whole layout. Let's go back to that spreadsheet idea for a second. The entire database file is like a single Excel workbook. And inside that workbook, you can have lots of different sheets, right? Well, in our database, we can have lots of different tables. So let's get to it and design our very first one. Okay, I know. You see this and it looks complicated. It's our first real look at another language called SQL. But trust me, it's way more straightforward than it appears. This is just the blueprint for our books table. And we're about to break down what every single piece of this puzzle means. So let's start with that first rule. ID, integer primary key. All this says is we're creating a column called ID, and it's got to be a whole number. But the really important part is primary key. This is the golden rule. It means every single book we add to this table must have its own unique ID. It's like a passport number for our data. No two can be the same. Next up, the title. Varchar 250 is just fancy talk for text up to 250 characters. But look at the rules. Not null and unique. Not null means you have to provide a title. You can't leave it blank. And unique means you can't have 2 books with the exact same title. These little rules are what keep our data from becoming a total mess. And finally, our rating. Float just means it's a number that can have a decimal point. Perfect for something like a 9.3 rating. And again, that not null rule is there, making sure every book in our collection actually has a rating. The blueprint is done. The house is built. Now comes the best part, the really satisfying part. It is officially move-in day for our very first piece of data. Let's see this whole thing in action. So, getting our data moved in takes 3 quick steps. First, we tell our cursor to insert the information. Second, and this is absolutely critical, we have to commit the changes to actually save them. And finally, we can use a free tool like DB Browser to peek inside and admire our handiwork. And here's the code that makes it happen. We tell our cursor to execute an insert command, adding our book into the books table. But then look at that second line, db.commit. Think of this as the master save button. If you forget to do this, all your work gets thrown away the second your script stops. This is what writes it to the file permanently. And voila, this is the payoff. After you run that code, this is what you'll see inside your database file. A perfect, beautiful, structured table. Our data finally has a permanent home. The ID, the title, the author, the rating, everything is in its proper place, following the exact blueprint we designed. Success. Okay, before we finish up, I have to give you a quick, friendly word of warning. We've seen how powerful writing these SQL commands can be, but that power is kind of a double-edged sword. It requires you to be perfectly precise. So, what happens if you're typing away and you make one teeny tiny little typo, a single letter out of place? We've all been there, right? With a lot of programming, you get a helpful hint. With raw SQL, well, things can get frustrating fast. Just look at this. Can you even spot the mistake? It is a single missing S. The correct command is values with an S. The incorrect one is value, no S. A tiny mistake like that is enough to make the whole thing break, and sometimes the error message isn't very helpful. So here's the bottom line. Writing SQL commands directly in your code is powerful, and it's a fantastic way to learn what's happening under the hood. But man, is it prone to errors. We've all spent 10 minutes staring at the screen only to find we missed a comma somewhere, which naturally leads to the big question. We've built our data a home, which is great, but getting the furniture in felt a little fragile. So is there a better way, a safer way to talk to our database using pure Python without having to type out these picky SQL commands by hand? The answer is a huge yes, and that, my friends, opens up a whole new world of possibilities. Thanks for joining this explainer.